Hello everyone, I hope you all are doing well. This side Priya Bhatia. And in this specific video, I am sharing a complete EDA concept in machine learning. Uh, EDA is nothing but exploratory data analysis. So if you remember, we have made several announcements in this YouTube platform as well. That at the very last week itself, we have started our new machine learning bootcamp and it's going really amazing. And I'm excited to share with you the recording clip of that bootcamp only, where in the last session itself, I have discussed about EDA, that how basically in the regression based problem, we can apply the exploratory data analysis. What are the statistical concepts required to understand that? Everything is in a detailed form. So please go through with that video. The only objective to share this recordings is that if there is any learner, if there is any student who is like कि he or she will be somewhat dicey कि करें कि ना करें join, right? क्योंकि when you are paying the money, you will always be have that fear कि whether I will be able to understand how the mentor is teaching or not. So यहाँ पर you can understand, because in between you will see sometimes learners are asking me the questions, they are unmuting themselves and they can interact with me, they can talk with me directly. So that is something which this live platform is giving to you. Otherwise the content is available everywhere. This is the only thing, this is the only advantage which you will be able to get, that will help you out in order to have a better learning in the ML part. And I'm very fortunate, I got so many enthusiastic learners in this batch. And you will also observe in this particular recording as well, that how they are so much interested, so much curious, and ask lot many questions as a part of EDA. I hope that you will also learn a lot from this specific video. So without wasting any time, now let's get started. And by the way, if there is anyone who wants to still enroll in this bootcamp, please go and check it out. Enrollments are still open. And if you will feel that up to बहुत सारे sessions cover up हो गए होंगे, no, it's just 1 week, 3-4 sessions have been covered up. And the beauty about these platforms is that I will provide you the recordings of each and everything. तो जैसे ही आप dashboard पे आपको access मिलेगा, you will get the recordings of all the live sessions which happened previously. So it's not that you have missed something. At any point of time, at your own pace, you can watch those recordings and you can join with us, with our community. So without wasting now any of the time, please try to watch the upcoming part of EDA, and please make sure you will watch that video till the very end. And you can also open at your screen whatever code I am writing here, and if you want to do a code with me, you can also do that. See, everyone's way of learning is different. If you feel that I want to focus just on the session and I don't want to write the code side by side, so in that scenario you can just maybe focus on what I'm doing here. If there is anyone who feel comfortable in writing the code as well, and that's how they will get the better understanding, so I would personally recommend for them that please do write the code on your own. You can refer my file, whatever things I'm doing side by side, and you can start your journey of writing the code in this live moment itself. So what I'm doing is I'm just trying to connect this collab file, and there is a button of sharing this notebook. So at every point of time, whenever you want to share this notebook to anyone, you can just share that. You can give them the edit access, as well as you can give them the view access as well. So for now, I'm just sharing this with anyone with the link, and I'm giving you a viewer access so that no one will edit my notebook. And there is a link of copying this, and I'm sharing this in my chat window. If there is anyone who wants to open this notebook, they can now easily open that and can see the code which I'm writing here. Although I will upload all these code files in the dashboard, so you will be able to get the access of everything, whatever we are covering up today. So let's try to start the session now. So first of all, if you remember in the last session, we have already imported all the required frameworks. Have you guys gone through the videos which I told you as a task? I think I have mentioned that.
Yes, ma'am. Ma'am, I've just not seen the last one, but I have seen the above two, the NumPy
What
and the
about
Pandas.
others? Everyone? Have you gone through at least once? Perfect. Good. Super. So let's move ahead, because that videos will be required in today's session. Okay. So you know about pandas now. I'm expecting that you know about NumPy now. You know about Seaborn a bit now. Still, I will give you a brief overview of whatever things I'm doing. But definitely, if you have to go through in a very much depth, please refer those sessions. Okay. Now let's try to read the file. Now you already know, I have shown you in the last class itself that we have a function of reading a CSV file. If you want to read some other file, we have a separate function. For example, read underscore Excel, read underscore CSV. So depending upon what kind of data you are reading, this function will get changed. You can refer at every point of time. Learners usually say to me that, Priya, what is the resource which we can refer while our learning journey of, coding part or understanding the conceptual part. So whenever we're talking about these frameworks, whether it's a NumPy, whether it's a Pandas, whether it's a Seaborn, whether it's a Matplotlib, I always say refer documentations. So what you have to do, for example, let's say you want to learn, for example, you have watched my videos, but obviously, I'm frankly saying no video will cover up everything, every functions that we have. If you have a time and if you genuinely want to do your own research after exploring the video part, you just have to do, for example, pandas documentation. Just explore this in the Google Chrome. And once you click on this, in the very first go itself, you will be able to see the documentation pretty well. Now, if you will just open this documentation, this is how it will looks like. Now, this thing will be same for all the frameworks which we are talking about in today's session, also in upcoming sessions as well. And I always say to everyone that whatever algorithms we will talk about in machine learning, whatever frameworks we will talk about in machine learning, the only source which I can recommend to everyone is the documentation, because see, these things keeps on changing, and on a daily basis there is some new update will happen, right? So if you will just refer some book, what will happen is in that book the updates will not be there for a framework, for a documentations part. The very first update happened in the documentations itself whenever developer makes some changes. So always remember that you will just keep on exploring this documentation part. So what you have to do is you have to click on this user guide and go to the user guide. Once you went there, you will be able to see that how to read these guides. Everything is there. Basic data structures in pandas. You can click on this. You will be able to see they are talking about series. They're talking about data frames. They're talking about how we can view the data. Although everything we will cover up in our sessions. But what I'm saying is, if you have a time at your end, see, everyone's time is different. Someone may be a student, someone may be an industry professional. Depending upon that, they have different responsibilities, especially if you are a student and if you have a time. I think as a student, the liberty of time that we have is really awesome, right? That time we will not able to get back when you are starting working, or when you get married, right? If you're a bachelor, again, you have a lot of time. So please try to spend that time in learning these documentations, refer these documentations, and try to read all the frameworks that we have in this ML, right? We tried importing data from sklearn initially. Its type was bunch. How is it different from data frame? I'll talk about it, don't worry. So you will observe that in future also, we will take few data sets which are already available in sklearn or SNS library. At that point of time, I'll talk about this part as well, don't worry. But data frame is important. It's a part of a pandas data structure. There are two types of data structures that we have in pandas. One is data frame. Bunch is not that much important. You will see it very rarely. But data frame and series you will see very often. Series is nothing but it's just one column. If you're picking up in a complete data frame, that you will call it as a series. And if you're taking a standard rows and columns, then that will be a part of a data frame. Okay. So now let's start working upon that. So what we have done is we have tried to read the data. Here, what I have done is I have tried to connect my file with the drive, and wherever my data is available. For example, in this case, you will be able to observe my data is available inside this machine learning bootcamp folder. So let me just check it out. It must be there below. So there are so many folders. Yes, this is the folder, right? So inside that, I will be having this housing.csv. So what I have done is, in the right side, I have three dots available with me. I will just copy this path and I'll just paste it over here. Once you will paste it over here, you will be able to read this, or your pandas framework will be able to read that CSV file. You will store that file inside this data. Now, this is a variable, and this is a data structure called as data frame. Now, to read anything, for example, you want to read the top 5 records from a data frame, the function name is head. So you will try to read this data frame and you will be able to get the topmost 5 records in this particular data. Now you can clearly see that in this specific data, we have multiple features, right? Price, area, bedrooms, in which automatically it is visible to us that price is something which is a target column that we have, and remaining things are just, you can say, features that we have, which basically helps my model to dictate that whether uh, the price, how much will be the price suitable for a given flat, right? Now, if let's say I want to see the type of this data, how can I check that? We have talked about this type function, which is basically giving me the idea that this type belongs to a data frame. Data frame. Now, if let's say I want to see how many number of rows and how many number of columns are there in a given data, so how can we check that? We have also discussed that we have a shape function available with us. And if you'll click on this shape function, we will be able to get an idea that in total, we will be having 545 number of records and 13 number of columns we have. So in a way, we will be having 13 features, but definitely we know that one feature out of them is a target one. And we will apply at the end of the day, linear regression algorithm to predict that price wala part, right? That is the major idea. But before jumping towards data modeling, we know EDA is something which we're supposed to do. So today we will try to focus on the EDA part specifically, and that is something which is very, very important to understand. So from here, we need to start, right? Shall we start further? Now, let's move ahead to the next important part, where let's say you want to get the information of the entire data frame that you have, okay? So there is a function called as data.info. Data.info. So if you just click on this function, you will observe that you will be able to get the information of each and every data feature that you have. For example, you can see that price is something which contains 545 number of entries. No entry is null, and the type is int64. Similarly, you can see area, bedrooms, bathrooms, stories, main road, guest room, basement, hot water heating, air conditioning, parking, preferred area, furnishing status, everything is available. And with respect to that, we can see that how many non-null entries are there and what is the type of each and every entry that is available with me, or each and every feature that we have. Now, you will be able to observe that almost 1, 2, 3, 4, 5, and 6 features are there, which belongs to the integer type, and remaining features belongs to a object type that we have, right? Makes sense? Now, if I'll ask from you that what do you think, how many number of null entries will be there? How many number of null values will be available in this feature? So what will be your answer? If I'll ask from you, how many number of null values are available in this given data set? What will be your answer?
Zero.
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 Zero. Okay. Why you are saying so?
No, because non-null, in each every record, non-null is present.
Since all fields are non-null. No, don't see like this. Just let me give you one simple idea. I think this is a very best case which we got in this data set. But what I'm trying to convey here is, so let's focus here. What happened? I don't know why it is not working. It's okay. So what is happening here is, if you can see, we will be having, you just have to see this number 545. Just check with the shape. The number of values that you have is 545. This count value will always give you the number of non-null entries. Now, in total, we have a shape as 545. And in this case, for every feature, we are getting how many non-null entries? 545 only. If let's say in future, you are having some feature in which you are getting 540, let's say. So in that case, you will be able to get an understanding that in a way, in this preferred area, 5 null entries are available and 540 are non-null entries. So at any point of time, if we will be having a null entries available, in that case, in the EDA process, we have to handle that very widely, very consciously. Now, don't worry if in this particular data we don't have any known null entries. Don't get worried that what will happen, how can we handle that, can you show that part. Don't worry, we will solve for every particular algorithm hands-on project. So in the upcoming data set, if it is not available in this, you will get in the upcoming one. And whatever steps we are not doing in this part of EDA, we will do in the upcoming part. But let me show you that what is the internal intuition behind this finding the null values, and why it is very, very important for doing that imputation part, means replacing those missing values or those null values with a proper accurate number, right? For that, a bit knowledge of stats is also required. And for that, whatever graph Prabhuth was asking about, that is also important to understand, right? So now that is one of the way where you can check that whether the missing values are available or not. So this is one of the way where you will be able to get the complete information of the data frame. This is one of the way. Okay? Other way could be where you can get the complete information of a data frame, where is that you can just apply one function called as isNull, data dot isNull. Now this isNull is kind of a, you can say, Boolean function that we have, which will either return true or false. So it will return true whenever the null values are available, and it will return false whenever the null values are not available. So if you will just run this code, you will be able to get an idea that it will return to us a complete data frame, and everywhere the false value is there. The simple reason is because in the above part itself, we have observed that there are, in this specific data, no null values are available. But let's say you want a sum of the null values. So there exists on top of this a function called as sum, which you have to apply. So what will happen is, for every particular feature that we have, you will be able to get an idea that how many null values are available. So you can clearly see that for this specific feature, we don't have a single null value which is available. Make sense? Uh, Nothing is wrong. You're talking about this known null part. So I just want to verify that whatever your understanding that you have is correct or not. You just have to check this, not focus on this known null word, because it will always be available. Just focus on this number and check this number with this shape part. Okay. Check the difference. Is there any difference between this number and this number? So your answer would be that as there is no difference between the shape of this number of records that we have, which is 545, and the number of entries which I'm getting in the information, both of them are same. That's why I'm saying that there is no null values available in this specific data, because this non-null word is always available. You will get 540 non-null entries, you will get 535 and so on. So that's not an issue, right? I hope it is now clear to everyone. Perfect. Shall we proceed ahead? Now, this part is fine that we don't have any null values. That's a good thing. But if, let's say, null values are available as in missing values for the features or zero as a data entry for the feature. Null values means that you will be having a missing values. Null values means, so when I'm saying null values, it clearly indicates that you will be having altogether a missing value available in that scenario. Or in other words, you can say nan is available, right? There is nothing is available. Nan is available, right? Null is there. If you're saying zero, zero is a separate entity, right? Zero is a separate number that you have. Now, in some specific data sets, it might happen that this zero number doesn't make sense. We will talk about in the upcoming part when we will discuss about the classification problem. In that case, there will be some data sets in healthcare in which zero doesn't make sense. In that case, again, you will do the replacement of this zero with some specific number, with, I would say, some reasonable number. Now, this process of using that missing values and replace that with reasonable number, or zeros to replace with some specific number, is called as data imputation in the world of machine learning. data imputation. If you want to replace any null values, or in other words, missing values, or in some scenarios, the zeros, to some reasonable number, how can we replace that? That's a separate discussion altogether, which we will do. But this process is something which we call as data imputation, right? Now, there are multiple ways to do the imputation. One way could be, which many people usually use, is via the measures of central tendency. That is one way. And second way could be via applying a ML algorithm, which is widely used algorithm, which we will discuss in our upcoming sessions, called as KNN, which will give the prediction that what is the suitable reasonable number could be for a given feature that we have. There are two ways to do the data imputation, very, very widely used in the industries. Either you can go for the measures of central tendency, or you can apply the ML algorithm, very widely uses KNN, which we will discuss in the upcoming sessions, to do the prediction that what could be the suitable number which we can apply in this particular data set. Now, what is the meaning of a measure of central tendency? Who will tell me?
Mean, median, and
Mean,
mode.
median, mode.
Mean, median, and mode, right?
Yes,
Okay.
sir.
So, very good. Now, anyone who can tell me, mean, median, and mode. So today we will talk about a maths part in terms of statistical portion, because in EDA, stats plays a very important role. I'll ask you a few questions, and accordingly we will see which particular thing we have to discuss in a detail and which particular thing we can skip. Okay. How basically you can evaluate mean?
It's the average.
It's the average, right? How basically you can evaluate the median?
Now it is the center point.
Middle value,
Is
basically.
In an
So if
ordered set,
let's
it's
say,
a middle value.
repeat.
In an ordered set or ordered values,
Yes, that's important. So first of all, you have to sort your data, right? It's an ordered set, the middle value. Don't directly say middle value. And that is what the people usually do the mistake in the median part. They directly, whatever data set is available, they directly do one thing. They will directly pick up the middle value. No, you have to first sort it out, and then you will have to find the middle part. Okay? What is mode and how you do the evaluation for that?
maximum frequency of
The most
Maximum
particular.
frequency, most frequent. Very good. So one thing is something which should be clear to everyone, that mode is suitable for a categorical based data. What is the meaning of categorical data, by the way?
It is not in numbers, basically. One, two,
Yes. For
three,
example,
discrete.
in our given data, if you can see main road, it is either yes or no. Guest room, either yes or no. Basement, either yes or no. Air conditioning, either yes or no. These kind of things are called as categorical based data. Can we say, everyone? It's a categorical based data. Whereas number of bedrooms, area, bathroom, it's a numeric data. Can we say? Because that's what we have seen, it belongs to integer type as well. Even in future, we will try to do the type conversion and convert from object to categorical itself, because that makes more sense. So anyhow, is it clear to everyone what is the difference between categorical and numeric? So whenever we are dealing with the categorical data, definitely the data imputation will be done via the mode. We cannot apply, obviously, in that case, mean or median. Does that make sense? Now, let's move towards the mean and median part. So let's say, okay, what is the meaning of outliers?
Which are not specific in the data. For example, in salaries, people have 30,000, 40,000 salary, but a person has 1 crore salary. So it is not usual, basically.
Yes. So anything which you can say is an exceptional value in your data set, that you can categorize it as an outlier. It can be something bigger. For example, what I think Mayank has given the example, I'm not sure. So what that learner has given the example, that 1 CR salary. So that is an exceptional thing. That is a very high extreme value. Or it can be very lower as well. For example, if I'll say 5K, 4K, let's say. So in both the scenarios, that's a part of an outlier, right? So Now, my question from you is that if, let's say, you get to know that in your feature, outlier is available, in that case, will you go for the imputation with mean
No,
or median?
we can go with median.
Again,
Median. Why is that so?
Because outlier is not
Because
it is not affected by outlier
mean is
median.
prone to affected by outliers. That
Yes.
will
So,
pull
in other words,
outlier.
can we say median is more robust to outliers?
Yes, ma'am.
And why is that so? The simple reason is that, for example, the kind of example which Mayank has given, if you try to evaluate the average salary of the people, and let's say you have an outlier of 1 CR, that average shifts a lot because of that 1 CR data point. But when you're talking about a median, as you have to take a middle point, and that 1 CR is the extreme value when you sort your data, so your median will not that much impacted. So always remember, whenever you are doing a data imputation, what we will do is we will try to check it out that how basically the distribution of our data looks like. So we will see the distribution of uh, every feature, distribution of each feature. Now, we will not do this part in today's session because our data is already having reasonable values. It doesn't contain any data, uh, null values, but I'm telling you because in future we will definitely do so. And at that point of time, I want you guys to let me know the answer that this is what we will do, Priya, in this case, right? So you have to check the distribution of each feature wherever the null values are available. And depending upon the kind of a distribution your data have, you will either do the imputation with a mean or median or mode. If it's a categorical based data, definitely you will go for mode. If it's a numeric data, you have to check that whether the distribution is a skewed or non-skewed. If it's a skewed distribution, in that case, definitely this contains outliers. You will go for a median imputation. If it's a symmetric distribution, in that case, you will go for a mean imputation in that scenario. So whenever we're talking about a distribution in stats, I hope you all know that we have two separate categories of distribution. One is called as symmetric distribution, and another one is called as, you can say, non-symmetric, asymmetric, or skewed distribution. Anything you can say. Okay? Symmetric is nothing but is a bell-shaped curve and is very famous by the name of, again, normal,
normal.
you can say, or
Gaussian.
Gaussian, you can say. So those people who already have watched my playlist of stats, they are already aware about all these concepts. I'm very confident, right? Because all these things I have covered up in a great detail in my playlist. In the skewed part, we have two ways. One is called as left skewed and another one is called as right skewed. So when you are saying left skewed distribution, it means that your data is inclined towards left and it forms like this. When you're saying right skewed, it means that your data structure forms like this, where on the right side, the peak is there, like this. Now, another interesting question which can be asked from you in this part is, I'm giving you again a brief recap of this part, that what is the kind of a relationship which normal distribution or a symmetric distribution holds with respect to the mean, median, and mode in terms of
Median.
central tendency. Yes.
Mean is equal to median is
So
equal to
in
mode.
that case, always remember, because mean is nothing but is the middle value. And because it's a symmetric distribution, it means 50% of the data lies towards left of this line, 50% lies towards right. So always remember, in this scenario, mean, median, and mode all are same. So this is an ideal case, which indicates that there are no outliers as such available in your data. So definitely you can go for simple imputation of mean or median. It's your choice. And at any point of time, if your data is almost inclined towards normal as well, you can go for a mean imputation. But the question comes when your data is either left skewed or right skewed, means it contains outliers. This is the indication that extreme values are there. That's why it is inclined towards extreme right or extreme left. So in that case, the question would be again same. When we are talking about, let's say, left skewed, In that case, what is the relationship of mean, median, and mode? The
Mean,
left skewed.
mean is less than, median is less than.
Okay, so someone is saying that mode is
Mean
bigger
is,
or mode is smaller.
mode is bigger. Mean is smaller than median, and median is smaller than mode.
Like this, is that correct?
Yes, ma'am.
Yes. So why is that? So now let's try to understand this. I think this is the curve which Prabhutva has also asked in the starting of the session. So now you can understand this point. Mode is something which is highest occurring point, right? This is the mode. Mode is the peak point, the highest frequency of any given data. Median is something which you can say is a middle point, and mean is the average point. So this is mean, this is median, and this is mode. So as you're reaching towards the right side of x-axis, you can clearly see that mode is higher value, median is lower than mode, and mean is the smallest one. And if you will talk about the right skewed distribution, relationship holds as vice versa. Mean is very much bigger than median, then mode. So this is how the complete flow of, I would say, distribution in the stats part looks like. Any doubt in this part, anyone? So whenever you're having this kind of a distribution of a feature, so what you will do is you will check the distribution of these features, and either the distribution looks like symmetric or it will be skewed. Depending upon that, either you will go for the mean imputation or median imputation. And if you will be having altogether categorical based data, then it is very easy to understand that you have to just directly go with the mode part. So far, so good. Shall we proceed? So this part we are skipping up. The only reason is because as of now, we are having a good values to go. So let's move ahead now with the next part of our journey. Data imputation, we are skipping. Maybe in the upcoming session, whatever knowledge we have gained till so far will be required and will be useful, right? Now, let's try to see the further things. Let's try to see the descriptive statistics of a given data. In that case, we have a function called as describe. So what will happen is you will be able to get for all the mathematical part, the description of a given data set by default. So here you can see whatever be the uh, features that you have, which belongs to, I would say, integer type. For that, you will be able to get the description pretty well. You will be able to see the price, area, bedroom, bathroom, stories, and parking. And for that, you will be having the count. You will be having the mean, standard deviation, min, 25 percentile, 50 percentile, 75 percentile, and maximum value. We'll talk about these percentiles also in the upcoming part of the session when we will be discussing about the box plots. But for now, this is how basically you will be able to get the description of any specific data points. Again, you can clearly see in this specific data that this count variable indicates known null entries, that how many number of known null values are available in every feature. Mean is the average. Standard deviation is the spread with respect to the mean value that we have. Mean value will give you the minimum value in a given feature that you have. Max will give you the maximum value. This 50 percentile is nothing but is the median value. And this 25 percentile is the median towards the left part of the portion, and 75 percentile is the median towards the right side of the portion. I will preferably give you one simple numeric example to explain you the mathematical concept of the calculation of these percentiles. Don't worry. But for now, I think this part is clear. But why is this required? Why is there any reason to check the description of this data? This description will help me to let me know that whether my data belongs to a normal form or not, specifically a standard normal form or not. So let's talk about that. What is the meaning of standard normal form? Who will tell me? Anyone, any idea? Now, these things will help me know that whether you have watched my complete playlist or not. Standard normal form, right? What is the meaning of that? So this description I am saying is giving me the idea that my data belongs to a standard normal form or not. So what is the meaning of a standard normal form?
It has a fixed mean or standard
It's
deviation.
the mean equal to 0 and the standard deviation of 1.
Very good. So basically, usually what happens, so you know what is normal form. Normalization means that you will be having that bell-shaped curve, right? It is having their own probability density function PDF. Now, if anyone is not aware, don't worry. Maybe in the upcoming sessions, we will deep dive into that part as well. But normal form, when you're saying normal data is there, so it doesn't have any stubbornness. It doesn't have as such any, I would say, constraint. It's just there is a function of a normal form that we have f of x, which it falls into, and that is how your bell-shaped curve looks like. But when you are saying standard normal form, it's a stubborn form of that, where it is saying that only the in the case of a SNF, standard normal form, the mean value will be always equals to 0, and the standard deviation will be always equals to 1. Now, when you are trying to see this data set, can you see the mean? Is this mean is closer to 0? Or is the standard deviation is closer to 1? So if I'll ask you in other words that is this data belongs to SNF or not, what will be your answer?
No.
No, right? So we have to convert this data into a standard normal form. Now, the another question which you will ask from me that Priya, why is this required? And is it required for all the kinds of data or not? So any answer before I will talk about this part? Is why is this required to convert our dataset into a standard normal form? Why I'm saying this part? Any idea? Any answers?
Yeah, Priya, because we actually need to convert the data, or we can say the different feature in a
Hmm.
standard scale. We are actually
Yes.
scaling to a standard scale because all the features having the different dimension or the scale of measurement.
And Vineet, why is it required if I'll ask from you further? Why
Yeah,
we have to scale it?
because why we are actually scaling? Because if we are scaling to a standard form, because we can say that different dimension will not contribute, or we can say that more importance will be given to particular feature because of that dimension or the scale of measurement.
Perfect. That's a very much apt answer, what Vineet said. That our model, at the end of the day, when you approach towards data modeling phase, right, after EDA, definitely in the upcoming sessions, we have to apply linear regression algorithm. And that's why we are preparing our data in a cleaner form. So definitely, you know that, for example, this area is a very big number and bedrooms is a very small number. And definitely it cannot jump towards 7420 at any point of time, right? So in that kind of scenarios, we have to take care that our model will not be more biased towards area, and maybe it will give more importance to those features which are having a very bigger value as comparable to those features which are not having that much bigger value. So it's very, very important, specifically in those kind of data sets where the difference between the numbers is very, very huge. If you are saying that Priya, I'm working with the data in which almost all the features are having equal values. For example, if I just remove this area, anyhow, price we have to remove only because it's a target column. In the future part, we will split our data into input and output features. We will do that. So if I'll remove this area portion as a feature, then I can say that, okay, all these features are just numbers only in the range from 1 to 10. So it's okay. You can go ahead without converting it into a standard normal form. But for now, we have this area as a feature which contains a bigger number, which contains a bigger value. I cannot do like that. So it's very, very important. And that's why descriptive stats plays a very important role. And that is the reason we have tried to get the description of our data. So is that uh, reason is clear that what is the purpose of this description part? First of all, it is basically helping me to understand, which basically we have already understood that, okay, there is no missing entries are there. But still, if you want to see from here, from this table also, it will give you the idea. Secondly, it will also try to help you out in order to understand that whether your data holds a standard normal form or not. And if it doesn't hold, in that scenario, is that required to make that into a proper scale? Uh, how will you get that idea? You will have to recheck your data set And you have to check that whether your dataset contains the columns or the features in which the scale is very much huge. The difference between the scales is very much huge. In that particular scenario, definitely it's very important to do the scaling part. And how can we do that? We will look into that aspect. But for now, the reasoning is clear for everyone. I'm
Uh,
not able to
Yes.
analyze from the graph why mean is in the left corner. I think you're talking about the above portion. Oh, where is that? So mean is nothing but is the middle value, right? So always remember when you are trying to plot x-axis. So in that case, the middle value where it lies is somewhere here, right? So it's a line. Maybe you can take some data set if you want for a left skewed data, and you can just focus on the actual calculation. You will be able to understand. Mean is nothing but in the x-axis, what is the actual middle value you have? That is what we call as average. But mode is something where you're saying the peak point, the highest frequency point. That's why mode lies towards the extreme right, but mean is at the exact middle point. And that's why mode is somehow very much higher as comparable to mean, Prabhutva. So you have to understand that mean is always the middle point. And let's say this is, suppose, a complete x-axis you have. So if I'll ask you, depending, I don't care whatever the distribution this data holds, mean will always be the middle point because it's the average you are trying to calculate. So this is always the mean. And if it's a skewed distribution, now you have to understand that if it's a left skewed, this looks like this only, where the maximum frequency will be there. That will be my mode. So mode will always be greater than the mean value. So middle is always mean. That is what this graph says. Okay. Any other doubt anyone is having? Anyone is asking something? There was someone.
Ma'am, Manoj here, ma'am.
Yeah, please, Manoj.
Ma'am, can you please go to Google Colab, ma'am?
Yeah.
Ma'am, in the standard normal form, ma'am, we need to drop this price column, ma'am, or how we'll do it, ma'am?
We will discuss that. I'll show you practically how we will do it. It's just that I'm as of now giving you the idea that what are the things that we have to do. We will try to first of all delete this price and then we will do it. So when we are doing the implementation part, what we will do, we will split our data into two components. Input features, where from area to this furnishing status, all these features will be there, and there will be a separate column, or you can say feature variable that we have which contains only price. So we will not scale this price part. We'll just scale the input features that we have when we do the implementation. Is it clear, Manoj?
Yes, ma'am. Yeah.
So whatever points I'm saying for now, you just have to take it in your head if you can, or maybe you can write it somewhere as a documentation that these are the things which we have to do, which we're supposed to do. How we do it, we will do it step by step, everything. Okay? Perfect. So descriptive stats की significance तो समझ में आ गई हमें. अब हम आगे चलते हैं to the next important point. In future, we will do the implementation of that conversion
Ma'am,
part.
one
Yes.
generic doubt, ma'am. Small
Yes.
generic doubt, ma'am. Ma'am, when we'll tell for scaling, we'll use the standard normal form. Scaling means just we'll increase the, or if something small value is there,
Okay.
right? We need to increase the value generally. Right?
No, scaling means that you are trying to specify a range. For example, when you're trying to convert your data set, when I'm saying I'm converting my data into a standard normal form, SNF, it means that you are trying to do a scaling. What is the meaning of scaling? That you are providing some range to the complete data set. For example, that range is from -1 to +1. So what is happening is you are saying that my complete data now lies from this specific range. It's not that area is a column which is having a bigger value, and let's say number of bedrooms is having some smaller values. Now what I am doing is, internally the importance of both of them signifies the same only, but area is also in the range from -1 to +1, and number of bedrooms is also in the range from -1 to +1. It's like providing a range. Okay, perfect. Now any other doubt anyone is having, please, you can just stop me at any point of time whenever you feel there is a doubt. That's the only significance of these live sessions. Okay, before I'll jump ahead. Any other doubt? Shall we proceed? Next part. Shall we discuss? I hope I'm not going very, very fast. If I'm going, please do let me know. I will slow down my speed. Perfect. So let's work ahead. And let's try to see the significance of next important part, that is the checking of a correlation coefficients. So let me write it down first. Correlation coefficients. So what there is a function in a data frame that we have, data dot core. If I just run this function, you will be okay. So here we will be having the object type as well. That's the thing. So we have to handle that first. So maybe what we can do here.
I guess we have to write columns is equal to a list of all the columns name.
Yeah, that we can do. But let's do one thing. First of all, let's try to convert this object type, whatever type we have, to a category type, because all these we know is a categorical part where it is having either yes or no. So what we can do, whatever be the features that we have, which is main road, guest room, basement, hot water heating, air conditioning, pref area, furnishing status, I'm trying to convert that into a categorical type. Now, how this conversion will happen? So in that case, I'm writing directly a code part. So here you can see we will be having this data frame data, and you can just try to use this function called as type. It will convert that into a categorical part. Okay.
We
So
can also use one hot encoding.
we will do that. We will do that. Don't worry. We will do that. So first of all, we will convert it into categorical part. Then we will do the one hot encoding. We will talk about that in a bit. Because this object doesn't make much sense, and we will try to specify a proper type of a data so that nothing looks vague here in this specific data set. I feel it's fine. So here we will be having all the features that we have, and we are converting it into a categorical type. Let's try to see the information again for a complete data, data.info. And let's try to see the information again. And let's see how it looks like. And now we have a proper categories. It means that now we have handled a D type of every particular data set that we have. So how we have done that? It's just that you have to use a function called as type, which will convert your data into a categorical part from that object type. The standard normal form does not necessarily have to be symmetric. No, it have to be symmetric. When you are saying normal form का मतलब ही ये है कि it is a bell-shaped curve only. It's a bell-shaped curve only. Okay. But the only condition or constraint on top of that will be that your mean will always be equals to 0 and standard deviation will be equals to 1. If there is any given data set, how we can convert any given data to this standard normal form, how this conversion will happen? There is a concept of something called as z-score, which will come into picture. I will talk about that after few minutes, that when we will do the actual implementation of this conversion part, I will talk about the internal intuition behind the z-score, that how is this actual conversion will happen, where we will get the mean as 0 and the standard normal or standard deviation as 1. And then I'll again show you the description so that you can verify that now whether the mean is 0 or not with the descriptive stats. Okay. So I hope it is clear. So do we convert our data into standard normal form after outliers elimination? We will come to this point. Just wait for a bit. Everyone is like, अभी बता दो सब कुछ है ना, थोड़ा सा भी सस्पेंस नहीं चाहिए हमें. Does it as type mean converting into character set into category, some range value? As type, yes, as type means that you are trying to convert this main road into categorical part. So you are saying to your code कि कोई भी type है, I don't care whether it's an object or integer or anything, just convert this particular main road variable or feature to the categorical part. And what is the meaning of category? Category means that you will be having a discrete value. So at any point of time, whenever in your data set, you will be having a discrete values like 0, 1, 2. There's some specific number is there, which is a class, which is a label, or you will be having yes, no, Boolean type of thing. So you are saying that convert that as a part of a category because it belongs to categorical data. So you have done that type conversion here from converting one type, which your code doesn't care, but you want that type to be converted into category. Is it clear, Prasanna? Afroz, I will take your question. Just give me a few minutes. We will talk about that. Shall we move ahead? चले आगे? ठीक है. Now let's try to do one thing. The question is there we will be having a categorical data, right? Acha, now how our data looks like, let me just again show you. After type conversion, you will be observing that you won't be able to see the much difference here. It's just that initially it was seeing as an object, now it is showing it as a category. Now, why we have done that? The major reason is that whenever you are passing this yes, no to your data set, your model won't be able to understand this textual terms. Always remember that whenever you are passing this textual form of data or a categorical form of data, specifically this yes, no, which is written in the form of textual part, right? Whether it is yes or no, your model will not able to interpret these meanings. So you have to map it to either maybe you are saying it as 1-0, कि yes indicate कर रहा है 1 को, no indicate कर रहा है 0 को. Or you have to do some you can say modeling, you have to apply some logic here in order to make this data set as a numeric one. That's the ultimate goal that you have to do, because your model will not able to understand the textual form of a data. So अब हम कैसे करें? So there are multiple techniques we have to deal with this kind of a data, to deal with this categorical data. A very famous technique which we called as a one-hot encoding. So let's talk about that in the very first go. One-hot encoding. What is the meaning of one-hot encoding? Maybe I will capture some image if I will be able to get, so that it will be easy for me to explain you the concept. This will work fine. Yes, this will work fine. Let me save this.
Priya,
Maybe, yeah.
Priya, before you proceed, I have one doubt. Can you go to this code file?
Okay. Yeah. Please tell.
Little bit above when we are
Hmm.
actually converting. Yeah, when we are actually converting it a category, here only we are changing the data type. We are
Yes.
actually not encoding any value, discrete value,
No.
something like.
No.
Then why actually we are doing this?
Okay. So what is the difference between object type versus category type? For this, you have to understand that part. So initially, we will be having a object type, right? By default. And we have done the conversion to this categorical type. So what is the difference between a data type called as object versus data type called as category? Then I think you guys get the better understanding. Int is, I hope it is clear, int is a numeric number. So let's not focus on that part. So object and then category. Any idea? Anyone who wants to say something? What is the
So,
difference? Huh?
so the
We have
object has mixed type of values, but in categories, it is optimized to store repeated type of values.
Can you give some example? What you want to say so that everyone will be able to understand? I think you're saying it correctly only.
Ma'am, for example, gender. So we have only two genders, for example, male and female. So it is repeated. It is repeated at a certain level. So we use category for the same. And in object, can have mixed value. For example, we can have numbers. We can have numbers plus string, numbers plus text. That type of stuff.
the pattern we
Okay,
are storing the data. It depends upon that one. In object, we have the mixture of that string or the integer in the data
correct,
which we are storing.
correct,
But in
correct.
category, actually, it falls in the different category. We can say that And
Yes.
as
And
far
we
as I
use
remember, this category is a specific to pandas data type. We do not call it as a Python data type, something like that.
Okay.
we
So,
also use category because it is faster. And when we are training the model, we need the speed to calculate.
perfect. Very good. Very good. This is a very crucial point, which I was just about to say. Actually, what happens is why this conversion have been made. So it's a very good question, by the way. So if sometimes I'm not sure that like people responded very fastly, and maybe they are aware about the differences very well. So if let's say anyone feels like that she has done the conversion, so we need at any point of time, like he has just posed me, right, why you have done the conversion. So this is something which I want from the entire part of the learners. If you know the differences, then so it is okay. We can move ahead. If anyone doesn't know the major reason behind doing so, please ask from me if I am not covering that up. Ki why you have done that? Because sometimes I assume that you know that stuff, but it might be the case that you don't aware, right? So when we're talking about this category part, usually what happens is, as people have said, that it is limited to the categories that we have in a given data. For example, we know that when we are talking about the feature called as, what was that, which I have done, main road. A main road है या नहीं, वो एक category है. वो yes or no ही होगा. That is not anything other than that. Will it make sense? So this is a category, that this feature of main road is a category. But by default, you will observe that whenever you are trying to create a data frame now, uh, never ever happened that it will give you a categorical type by default, until or unless anyone has already claimed that data and is giving to you. Raw data will always provide you object type, क्योंकि वो क्लासिफाई उसके अंदर कर ही नहीं पाएगा कि वो क्या है, मतलब it contains some strings or it contains some integer. Object में सब आ जाता है. It's not a proper classification. But in category, we are classifying our data that it is a categorical part which contains a specific values, either 0 and 1 or yes or no, right? Like that. Now, why we have done that? Because when we are training our model, it is more memory efficient. Because हमने classify कर दिया कि ये categories है जिससे हम deal कर रहे हैं. But when you are saying object, because it can contain anything, it can contain multiple things, it is not at all memory efficient, right? So we have to write a code which is memory efficient, right? We don't want to waste or have a code which is not at all optimized. So why to put a object type? Because if we know that this is a categorical part, this is a category which either belongs to yes or it belongs to no. That's the main reason why I have done that type conversion before doing that step of handling that categorical data. That's the main reason. So always remember, when your data contains a limited set of values, right? In that case, it is always a categorical data. Object में तो वो कुछ भी enter कर सकते हैं, yes no के अलावा there can be any other entry, and your record will not throw any error as well, right? In future, let's say you are passing and deploying this model, and let's say user is entering some data points. ठीक है, आप ये सोचो कि आप अपने मॉडल को डिप्लॉय करने जा रहे हो और वहां पे कोई भी बंदा बैठ के आपका इनपुट फीड कर रहा है. नाउ इफ it is an object type. In that case, if he can feed any string, any number, that also your model will entertain. It will not throw any error. And in future, obviously predictions will not be correct. क्योंकि उन्होंने तो कुछ और ही लिख दिया, yes no तो लिखा ही नहीं. But if it is a proper type, in that case, it will give the error to the user that you have to write a proper entry. Then only you will be able to get the output. Then only you will be able to get the result, right? That's the main reason that why this type conversion is important. First thing, for the memory efficiency. Second thing is that when you are trying to deploy it, user should know that this belongs to which particular type, what kind of entry they have to put. It's not that they can put any other entry, because when we're talking about object, it can hold numbers, it can hold strings, like it can hold anything. It's an object and many more, you can say. So here we are not putting any restriction on this type. That's the reason. Vineet, is it clear now?
Yes, clear.
Okay, let's move ahead then. We are talking about one-hot encoding. So let me first of all explain the concept behind that, so that if there is anyone who is not at all aware about this part, they will be able to understand. And oh, then maybe we can move ahead. I have saved the image, I think. Let's see. Okay, that is the issue. Okay, perfect. So you can see, right? What is this one-hot encoding says? Again, there are multiple techniques we have. There's label encoding also. So I'm planning to cover up these techniques step by step in different kind of data sets. We will cover up different things so that every point of time you're learning something new, right? So today we'll try to handle it with a one-hot encoding. What does that mean? Simple meaning is that, for example, you will be having a feature named color. Again, it's a, let's say, categorical based data where a user can either have a red color or a green color or a yellow color. Let's say three colors are there: red, green, and yellow. And what I want is I want to convert that into numeric data. Now, I told you what is the reasoning behind that. The reason would be that our model will not able to understand this yes, no, or red, green, yellow, what they want to signify. So in that case, what this particular one-hot encoding technique does, it takes whatever be the unique values you have. For example, in this case, we do have red, green, and yellow. So it should create another column as well, which is yellow. So in that case, what will happen is, for example, red is a main column that we have. So wherever the red is available, it will mark it as 1, right? It will mark it as 1, and remaining values will be 0. Similarly, wherever the green is available, it will mark that as 1, and remaining values will be 0, which you can clearly see on my screen. So this is the working of one-hot encoding, in which the good thing will be that your complete data will be automatically converted into ones and zeros, which your model will be able to understand that wherever the 1 is there, it means that this column belongs to that particular pattern, that particular category. But the drawback is that when you will be dealing with a more features, when you are having, let's say, millions of features, you're working with the real-time data, in that case, it will extend more features, right? Because whatever the unique values you have, for that, it will try to create a separate features altogether. So that's a disadvantage. What is the pros? I'm talking about both of them. The pros will be that it will be able to efficiently handle textual, or you can say not textual, categorical data, and create specific columns for all categories, right? Columns for all the categories that we have. But what is the cons? That obviously there will be an increase in the number of columns. Increase in the number of columns. So there is something called as dimensionality part, curse of dimensionality, which we will cover up in the later on part when the time will come. So in that case, you will observe that sometimes this is also an issue, that we have so many columns and our model will be confused. In that case, we will be having techniques to reduce the dimensions. That will be a separate discussion altogether, which we will do in the upcoming week. But for now, because we're just starting it out, we will do the one-hot encoding, which is very, very simple. So what it will do, again, I'm repeating, it will just directly take the separate categories that we have, mark it as a column separately. Wherever that value is available, it will mark that value as 1. Remaining values will be 0. So shall we proceed ahead to the implementation of the same part? Any doubts in this part, anyone?
Ma'am, in this table, it is showing that the yellow column dropped to avoid a dummy variable trap. So what is dummy variable trap?
Uh, we will talk about this. Don't worry. It's just that they are saying that see, we will, when we're trying to do the implementation of this, we will use something called a dummy. So let's do the implementation first. Then I'll talk about this particular part again. Dummy variable trap. What is the meaning of that? It should showcase that, but we will see on our data first, and then we will talk about this. So shall we implement this stuff? How basically we will be able to do the type conversion from this categorical data to the numeric feature that we have?
Yes,
Perfect.
ma'am.
So let's move ahead. there is something called as feature in pandas, which is get underscore dummies. Let's discuss that. First of all, I'll show you the stuff, then only you will be able to understand. So what we can do here, we will say data. Let's try to create a separate data frame altogether so that we will not touch upon our original data that we have, which is available in our data itself. So let's create a data frame where you can say pd dot get underscore dummies. Now, this is a function which will basically internally is doing the thing which I'm talking about, the one hot encoding part. So you can see it will convert categorical variable into dummy or indicator variable. What is the meaning of this? Dummy, you can say ki it's kind of memory which it is taking up and it is giving a dummy variable for that particular part. कि कुछ भी नाम मतलब वो दे रहे हैं उसी डेटा फ्रेम को. मैं आपको जब कॉलम दिखाऊंगी ना हेड का तब आपको समझ में आ जाएगा कि डमी का मतलब ये क्या बोल रहे हैं. लेट मी जस्ट शो यू द इलस्ट्रेशन फॉर दिस. Get underscore dummies and inside that you can write your data which you want to convert. And let's try to do this first and let's see how it looks like first of all. Maybe let's run this code. And let's see how will it looks like. Data frame dot head. देखते हैं क्या हुआ. Now, what is this dummy? Let's try to understand that aspect as well. Maybe let's see what is happening. ठीक है. तो यहाँ पर क्या हुआ? Main road no, main road yes. So in the main road no, you will be able to get few entities. Let's do one thing. Maybe let's try to analyze the top 30 records. So what you can do, you can just tap on this number as 30 and you will be able to get the entire result. Now let's try to see more carefully what happened here. Let's go to this thing. So first of all, can you observe this? How is this columns looks like? Whatever be the number of categories you have in each and every particular feature, so that specific category is converted into feature name, right? This dummy name is this, where it will take by default your feature value and then it will provide underscore whatever be the category you have, which is no and yes, no and yes, yes, no, yes, and so on. So if you will just go towards the extreme right, what you will be able to observe that whatever be the categorical entities we have, everything is just converted into true and false. Initially it was yes and no, now it is converted into true and false. So this particular variable which it is trying to create, I have not created that. This is the by default, you can say internal developer have designed this code in such a way that they have mentioned that the way it will try to create a column is this only, where we will be having that column name underscore whatever be the category we are providing to that particular aspect, right? Is it fine so far? Any doubt in this part? So let's do one thing. Let's open this documentation of get underscore dummies pandas. So you can see in this case, it will convert the categorical variable into a dummy variable. What is a dummy variable? I hope now it is clear. Dummy means जो नाम हम देख रहे हैं उसमें वो उसको ही dummy बोल रहे हैं, वो variables को ही dummy variables बोल रहे हैं या indicator variables बोल रहे हैं, ठीक है? So each variable is converted in as many 0 or 1 variables as there are different values. Columns in the output are each named after a value. If the input is a data frame, the name of the original variable is perpended to that specific value. That's what I'm trying to clarify here. Now here we will be having so many parameters which you can see. We have taken all the other parameters as by default and we have just put our own data on top of that, right? There is some parameter called as drop underscore first, which is by default a false value. Now let's try to put it under the value as true and let's try to see the significance of this feature. Maybe you can observe this and do let me know what do you think is the significance of that. Maybe I'll make it true. ठीक है, दोबारा करते हैं एक बार. Let's see what will happen. So any idea, any intuition, what is the difference between this part of a code where by default it was
Ma'am,
taking the value as false and now it is taking its value as true?
it
The
removed the
category.
first value basically, the categorical column, the second one, drop
Uh,
first.
चलो एक काम करते हैं. Maybe you can explain me. Can you explain me with the help of examples? So here I'm not taking this, and this is my data that I have, data frame underscore one. And if I'll show you this part for the top 30 reports. So what I'm asking is, can you now explain the difference? That what is the difference between this output which I'm getting and this specific output which I'm getting?
So previously, for example, in main road guest room, we were having that columns as yes or no categorical columns. But when we have done that into true, we have removed the initial one, the main road column. Uh,
Okay. Okay.
Priya,
So,
out of the category, suppose in particular feature, we have only two category, then
ठीक है.
only one category will be referenced as a column.
Perfect. Perfect.
It will be
Okay.
dropped by default.
One more question. Okay. I think whatever they are saying is pretty much clear to everyone. The only difference between this drop underscore first feature, which is a parameter that we have in the documentation, which you have seen, it is by default false, and I have made it to true. So I'm asking from them that what is the significance of that with the help of this example, the output that we are getting up. So what they are saying is that, Priya, before that we are getting the two categories because main road is having two categories, which is yes and no. And now when you're taking it as a drop underscore first as true, so you can clearly see that it is dropping the entire that no wali category for all of the features that we have. And just looking into this yes wala part, it is giving us the result. ठीक है. Now my
But
next question is that
Ma'am,
is the first approach is better or second approach is better?
second one.
Okay. Why is that so?
the
See,
computational
we are
power.
we are getting actually two benefit here. First,
Okay.
we will be having less number of features. So the curse of dimensionality probability will be reduced here. Second thing, we will one I don't know the name of person who was asking that dummy variable trap. Here
Yes.
we are actually removing the dummy variable trap because
Very
in
good.
that case the multicollinear features will be removed here.
Correct.
मैम मेरे को इसकी इम्प्लीमेंटेशन काफी मतलब कंफ्यूज कर दे रही है. मैम फर्स्ट ऑफ ऑल जब हम लोग ने इसको कन्वर्ट किया तो जब इसे डमी वेरिएबल्स बनाए हैं तो मैम ये किस हिसाब से इसने यस और नो लिया है? क्या ये हमेशा मतलब बाय डिफॉल्ट ये यस या नो में तोड़ता है या फिर ये कुछ और भी मतलब वैल्यूज हो सकती है? फिर
Anyone who
इसके
wants to answer this question?
Yeah, Priya, I will answer.
Yeah, please.
I don't know who was asking the question.
Prabhutva. Prabhutva.
Prabhutva, see, uh, I will explain you in the Hindi. Suppose we have a one feature, okay, that is gender. In that feature, we will be having only two possible value, either male or female. Okay. So if we are converting these two category in particular two features, then if we are creating two separate features, then there is no need to create these two features because a person will fall either in the one category, that a female or the male. That is why if we are taking as a female, actually the person is a female, then at that point that female will be having the value of 1. So if the person is having the if person is the male, then by default it will take the value as a 0. So unnecessary column we are not creating here. You got my point?
यस. और मेरे को इसके अलावा मतलब ये समझ में आ गया पर एक मेरा मतलब बेसिक क्वेश्चन है, मतलब डमी से रिलेटेड, वो ये है, जैसे मान लीजिए हमारा फीचर है और उसकी वैल्यू है, जैसे मान लीजिए वो दो कन्वर्ट कर सकते हैं, या तो वो आंसर देगा ट्रू या फॉल्स में। तो जब हम लोग इसको वन हॉट इनकोडिंग कर रहे हैं, व्हेन वी आर कन्वर्टिंग इट, देन इफ व्हेन द कॉलम्स आर बीन क्रिएटेड बाय द कंप्यूटर, then also it will be create the column name as yes or no, or it will convert it as true or false. That's my basic question.
No, here actually we are suppose in a
It
feature
will
we are
convert
having
into
two value,
true or false.
either true or false. Okay.
Yes.
So here when you are saying here that main road underscore yes, so वहां पे क्या कर रहा है कि जिस भी ऑब्जर्वेशन पॉइंट में यदि मेन रोड यस है तो वहां पे वो ट्रू कर रहा है, और यदि उस ऑब्जर्वेशन में यदि मेन रोड यस नहीं है वहां पे फॉल्स है तो वहां पे वो फॉल्स करेगा।
Okay, so
Okay,
Prabhutva,
understood.
I like what you are saying कि I feel what you are saying is कि अगर आपके पास में आंसर yes no ना हो यहाँ पे और true false हो, तो वहां पे आपका कॉलम क्या बनेगा, आप ये पूछ रहे हो, राइट?
Yes,
तो
ma'am.
उसमें क्या होगा कि गेस्ट रूम अंडरस्कोर जैसे ट्रू हो जाएगा, जो भी आपकी वैल्यू होगी ना यहाँ पे लिखी हुई कैटेगरी की, वही वैल्यू का
यही
अंडरस्कोर बना
बोलते
के
हैं
वो
सर।
बना देगा।
ओके मैम,
ठीक
अंडरस्टूड।
है,
मैम
वही
बेसिकली
उसमें डॉक्यूमेंटेशन में लिखा हुआ है, इफ यू कैन जस्ट अगेन रीड दिस लाइन, columns in the output are each named after a value. If the input is a data frame, the name of the original variable is perpended to the value. मतलब ये बोल रहे हैं इस इंग्लिश में कि आपका जो कॉलम है जिसकी जो वैल्यू होगी ना उस कॉलम में, तो जब डेटा फ्रेम क्रिएट होगा तो जो भी ओरिजिनल वेरिएबल है उसके बाद वो वैल्यू उसमें ऐड हो जाएगी। ये इसका हिंदी वर्जन है जो मैं आपको बता रही हूँ। ठीक है, तो डिपेंडिंग अपॉन ट्रू फॉल्स है, मेल फीमेल है, तो वही वैल्यू आपकी ओरिजिनल वेरिएबल के साथ में परपेंड कर देंगे डमी वेरिएबल को बनाने के लिए। आई
We
होप
also
नाउ
have
दिस
we also have
क्या
an
बोल रहे
example in our own data set, furnitures. So it is divided into
हाँ,
three
वेरी गुड,
features.
दैट्स अ गुड ऑब्जर्वेशन। तो अगर आप यहाँ पे देखो, कंफ्यूजन आपकी बिल्कुल खत्म हो जाएगी अगर आप यहाँ ऑब्जर्व करोगे। जैसे आपके पास में आपका जो मेन फीचर था उसमें, इफ यू विल ऑब्जर्व, वी हैव टू कैटेगरीज ऑफ फर्निशिंग स्टेटस, फर्निश्ड और सेमी फर्निश्ड। तो यहाँ पर क्या हुआ कि जो हमारा नाम आया डमी वेरिएबल का, वो क्या आया, अंडरस्कोर फर्निश्ड आया, अंडरस्कोर सेमी फर्निश्ड आया, अंडरस्कोर अनफर्निश्ड आया, ऐसा नहीं है यस नो आ गया। तो आई होप नाउ इट इज प्रेटी मच क्लियर टू
यस
यू।
मैम, नाउ मैम क्लियर।
Okay, perfect. Shall we proceed ahead to the next part? Any
यस
other
मैम।
confusion anyone is having?
Ma'am, I had a query.
Yeah, please.
Ma'am, a feature does not necessarily have to have just two inputs, right? Like for it to be
हाँ,
categorized.
जरूरी नहीं है, बिल्कुल सही बात है, yes.
So, ma'am, if it accepts more than two inputs, so
हाँ,
how will it go? Because like
you
then
can
to
see, right, in this case when we're talking about this furnishing status, let's take the same example. In this we don't have two categories, we have three categories: furnished, semi furnished, unfurnished. So it will take three columns accordingly. So whatever the number of categories you have, accordingly it will try to create that many number of columns.
Ma'am, basically, we can take the example that you have pasted the image, the color one. We were having red, green, blue
Yes,
colors, and we have converted each color value into a new column. And for
yes.
example, if the value of color is red, we will
Hmm.
assign one or two to red, and we will assign zero or false to other columns, like that.
Perfect. Is it clear
Ma'am,
now?
now can you explain dummy variable trap now?
Yeah,
Why it is?
I'm coming to that point now. So simple one hot encoding says कि we are trying to convert whatever be the number of categories we have, red, green, and yellow. So we have tried to create a separate columns for that, and we are trying to classify that 1001 like that. But when you're trying to make one extra parameter by saying drop underscore first is equal to true, so what it is doing is it is dropping one of your, I would say, feature or category in the given data frame that you have. So for example, यहाँ पे हमारे पास three categories हैं, we have three categories. So it is just dropping that yellow wala one. Why is that so? Because automatically, if let's say you are saying any category will belong to red, so in that case definitely green से belong नहीं करा तो yellow से भी belong नहीं करेगा. any category which doesn't belong to red and green. So it is an indication that if, let's say, we will be having only 3 categories, which is red, green, and yellow, so it will belong to yellow only. So our model will be able to understand. So why to try to give a separate 3 columns altogether? This part, this specific parameter, which is drop underscore force first is equals to true, is helping us in 2 ways, which I think Vinit has already explained in a pretty much amazing manner. That when you're trying to define this parameter in this one hot encoding part, what is happening is, one thing which you will observe is you will be having a lesser number of features. And means you are trying to, for example, if let's say in any of the category you have 2 features, like let's say you have 2 categories, yes and no. So it will just give you the example answer of yes. It will not give the answer of no. Why? Because if I will get to know कि yes पे ये चीजें belong करती है, so automatically I know that no पे vice versa चीजें belong करेंगी, right? Similarly, if you will be able to observe in this output, in the previous case, we will be having 3 features for the furnished, semi-furnished, and unfurnished. But when we are saying the drop underscore force as true, we just have only 2 features available with us, which is semi and unfurnished. First वाली जो category थी वो remove हो गई. First वाला जो feature था, first वाली जो category थी वो remove कर दी हमने. Why? Because if I will be having all the n-1 number of categories available with me, so automatically the pending one we will be able to detect, or our model will be able to understand. That is the major reason why in this case you cannot see that yellow is not available, because automatically this red and green is giving an indication that at any point of time, if anything is not belonging to red and green, it will belong to yellow only. So why to take extra feature? अब ऐसा क्यों कर रहे हैं? Because as I told you, higher the number of features, higher the computation. So there is a concept of curse of dimensionality, which I think Vineet also has said. So what is that meaning? The simple meaning is that if you will be having a very huge amount of features in your data set, in that case, it will negatively impact your model. Means your model will be confused and it will not give you a good accuracy. So in that case, to avoid this part, we will always prefer, when we are applying a one hot encoding, to use this parameter of drop underscore first as true, so that it will drop the very first category in each and every categorical feature that we have. And this is how we will be able to get the final result. So in future, we will be working with a data frame, not working with a data frame underscore 1. That's the main reason. So is that part is pretty much clear to everyone? Any doubt in this part? Anyone? Makes sense? Any doubt? Okay. Let's do one thing now. Data frame dot core. So now can you see, we will be easily able to see the correlation coefficient of each and every feature that we have, which I was talking about previously. So this core feature is providing me a correlation coefficient of any 2 features that we have. Always remember. Now, let's try to understand the significance of this correlation coefficient. Anyone who can explain me, who is already aware what is correlation coefficient and what is its significance?
Mainly used
Ma'am, it
for
describes the degree to which 2 variables move in relation to each other.
ठीक है. And why we are trying to evaluate that? Why we do care about that stuff?
because we don't want to give
In
the model
EDA?
too many features. Like you said, too many dimensionalities will it's an overhead to the model. So
Can
we
you
need to.
speak again? Your voice is breaking in between.
Am I audible, ma'am?
Yes, please go ahead.
We don't want to give too many features to the model. So if we give too many features, then the model is going to take too much time to compute the result.
Okay. So first of all, when we're talking about this correlation coefficient, it basically indicates the like how the 2 features are correlated. For example, again, its value belongs from -1 to +1. If let's say you are saying that the correlation coefficient of two features. Let's say I will be having feature F1 and feature F2, let's suppose. And you are saying that it is positively correlated and is having a value near to +1. What is that meaning? The simple meaning is, in that scenario, you want to say that as the value of F1 is increasing, the value of F2 is also increasing. That is the simple literal significance of having a positive correlation, and that too near to +1, right? You are saying that as the value of F1 is increasing, the value of F2 is also increasing. What is the meaning of negative correlation -1? So positive means F1 is increasing, F2 is also increasing. When you are saying negative correlation is there, so this is the meaning of positive correlation.
The
Negative
negative one
correlation
means
meaning, yeah, F1 is
when
increasing,
one
vice versa. One is increasing, other one is decreasing. That is the literal meaning of negative correlation. And let's say if you are saying that, let's assume I will be having a 0 value as the correlation coefficient value. It means that those two features are not at all correlated, right? Now the question is, the biggest question is, now if you want to understand the maths behind this, how can we evaluate that? Please again refer the videos. I will not go in the very much depth of mathematical part in the way of evaluating this part, but I'm giving you literal significance of that stuff, that why we are doing this as a part of a EDA. The important answer is that in this specific scenario, if let's say when you are saying my two features are either positively correlated, that is approximately equal to +1, or when you are saying that the two features are negatively correlated, means approximately equals to -1, it indicates that somehow these features are giving similar information, which is responsible for the prediction of a given house. Prediction of a house. Because we are solving this problem only for now. So it clearly indicates that these two features are giving me a similar kind of a intuition, similar kind of information. So why to take both of the features? If let's say I'm saying that there are two features F1 and F2, and they're trying to convey the same information only when the prediction will happen at the time of the testing part. So why will I train both of them? Why not to delete any one of them and take the other one? So that's the approach which we usually do. So at any point of time, if we will be having a very high correlation coefficient, usually we prefer that it will be, if it is more than 0.80 or 0.85, in that case, we will prefer to remove any one of the feature and we will move ahead with the other feature. So any one of them you can remove, it's your wish. So that your features, it's kind of a feature selection technique. So there is a term called as feature selection. And this method is a part of a feature selection, where what you are trying to do is you are trying to say that if my two features will be highly correlated, in that case I will remove any one of them and I will proceed with any other feature that we have, so that I will be able to reduce the number of features, which will anyhow will help me to reduce the computationally extensive task of doing the modeling part. So if we will see this part, we can also create a proper heat map of that to visualize the same thing in a much better way. So how can we create a heat map? For that, I will use that plt.figure. And inside that, I can define the fig size. For example, if let's say I want to increase the size of a figure as maybe 15, 15. And after that, there is in the Seaborn, for all the visualization plots, we will use this Seaborn package, Seaborn framework, where you can say sns.heatmap. So these things you will get to know from that videos. If you have already watched, you know that. If you don't watched, you can just listen here. You will be able to understand these points on the way itself, right? So you can just here mention what kind of data you want to create a heat map for. So I want to create a data frame.core. So you will call that function here. And after that, there is one parameter which I'm making it as a true and not is equals to true. I'll showcase you what is the significance of this parameter as well, just like the way I have done for the one hot encoding part. And after that, I'll say plt.show. Let's see how this heat map looks like. Same results. It's just a beautification of that, you can say. Let me show you first, and then we will see each and everything. Perfect. Can you see a beautiful heat map is coming up where the same data entries are there inside this heat map 1.54.37.52.42, which was already there in this case as well. It's just that we have designed a proper picture for that, where I will be having a variable name on the x and y axis, and a proper correlation coefficient value is available with us. Now, what is the significance of this variable? If you will just remove this, by default, it is false. So what will happen is, you will be able to observe the values available inside that picture is not there, right? Because I want that values to be available, that numbers to be available. So it would be great if you can just apply that parameter as true, and it will look now perfect, where we will be having for every two features that correlation coefficient value. As I told you, it varies from -1 to +1. So you can see all these values are available with us. Now, it's your task to check it out, that whether we have any two features which is having a very high correlation coefficient. Can you see any of these values in this given chart?
Ma'am, 1 1 1 1 1.
Let me talk about this 1 1 1 in the diagonal part. So you can see price is at the y-axis. Can you see that? Price is at the y-axis. So if you will just check this price in the x-axis, these two are same. Now you can understand, right? If you are trying to see the correlation between the same features, it will always be 1. तो
Yes,
हमें
ma'am.
तो दूसरे के साथ में देखना है. We want to find out the correlation coefficient value with respect to another feature. Same में तो it will always be 1. It makes sense. So that's why you will always observe, whenever you will create a correlation coefficient, your primary diagonal means the kind of diagonal which I'm showcasing you here. My Epic pen is not working as of now, so I hope you can understand my point. So you will observe that in the x and y axis, wherever the variables are same, or wherever the features are same, that will always be 1. That makes sense as well, right? They are highly correlated, so that's why the value is 1. But apart from this, is there any two features that we have which are having a very, very high correlation coefficient, maybe in a positive direction, maybe in a negative
Yes,
direction, we
ma'am.
don't
Ma'am,
care.
0.037. Parking and
It's a
what?
0.03, not 0.3.
Ma'am,
0.3 भी बहुत.
Color 0.49, something like that, 0.59.
Just
Below.
What are those two features?
Can you scroll down, Priya, a little bit? It's 0.59, minus 0.59.
Hot
0.059,
watering,
I can.
yes.
Okay. This is where we have a highest, right? So with the help of these colors also, you can clearly see. So -1, 0.8, 0.6, 0.4, its range they are specifying. So minus 0.59 to this one. What are these two features? Okay. Furnishing status, semi-furnished and unfurnished. They are highly correlated, but it's not that much high. But obviously, in the entire space that we have, whatever features we have, it is the highest. We don't have, I think, anything extreme apart from this. Or do we have?
No.
In the positive direction, we don't have any other color. In the negative direction, I think that is the highest that we have.
मैम हम लोग
So,
हाईएस्ट कोरिलेशन दूसरे फीचर्स के रिस्पेक्ट में देखते हैं कि जैसे मैंने बताया
yes.
0.037. सो इट इज नॉट हाईली कोरिलेटेड बिकॉज ऑफ द 0.0071. एम आई करेक्ट मैम?
देखो, हाईएस्ट का मतलब है कि वैल्यू 1 से नियर होनी चाहिए, +1 से या -1 से. तो जब आप
अरे
बोल रहे हो
ओके ओके,
जीरो
सॉरी
पॉइंट
मैम,
जीरो
सॉरी मैम.
इट इज नॉट गुड.
अंडरस्टूड
ओके,
अंडरस्टूड.
ठीक है. So for now, we are picking up all these features with us, right? Let's see how the performance could be, because we don't have any extreme feature in which the correlation coefficient is more than 80% and even 70%. 60% is there almost, but we'll not get rid of that. And I think we can move ahead with respect to that part. How does exactly one-hot encoding promote EDA? Afroz is saying. Afroz, is it clear, or do you want to clarify again? One-hot encoding is required because, as I told you, when you are directly passing or feeding your data, this values of yes and no, your model will not be able to understand the significance of this yes and no, what they want to, tell to the model. Your model doesn't know the meaning of yes and no. Your model knows 1 and 0, true and false. So what you are doing in this one-hot encoding in EDA part, You are trying to specify or you're trying to create that dummy variables so that your model will be able to understand the internal intuition कि yes का मतलब क्या है और no का मतलब क्या है. That is the significance. ठीक है? Is it fine, Afroz? Vinith, do you have any question?
Yeah, Priya,
Hmm.
the correlation plot we have actually plotted, उसमें हम
Hmm.
लोग देख रहे हैं कि ये जो कैटेगरी है फर्नीचर में, उसी के बीच में हमारा कोरिलेशन उतना हाई नहीं है. एज्यूम करो कि ये मोर देन 80% होता है. तो इस
Hmm.
केस में ये दोनों एक्चुअली कैटेगरी कैटेगरी को ही रिप्रेजेंट कर रहे हैं. तो इसमें हम लोग इसको ड्रॉप नहीं कर सकते ना.
अगर मान लो आप ये बोल रहे हो कि सेमी फर्निश्ड और अनफर्निश्ड के बीच में लेट्स से 0.80 होता, तो
हाँ.
इसका मतलब क्या था? आप खुद सोचो कि मतलब अगर 80% ये कोरिलेटेड है, व्हाट डज दैट इंडिकेट इन अ गिवन डेटा सेट? व्हाट इज द इंट्यूशन लेमन टर्म में अगर हम बात करें? हम ये बोल रहे हैं कि सेमी फर्निश्ड और अनफर्निश्ड का जो डेटा है ना हमारे पास में, वो 80% बार सिमिलर रिजल्ट दे रहा है. इसका
हम्म.
मतलब, इसका मतलब क्या है? इसका मतलब क्या है? मतलब इंटरनल इंट्यूशन क्या हुआ इस टर्म का?
मतलब उसका ये हम लोग बोल रहे हैं कि ये ज्यादा कोरिलेटेड है. इसको मतलब लेमैन टर्म से बोले तो ये दोनों में से किसी एक को यूज करेंगे तो हमारा रिजल्ट सेम आएगा.
रिजल्ट सेम आएगा. इसका मतलब ये है कि कहीं ना कहीं डेटा सेट में लोग सेमी फर्निश्ड और अनफर्निश्ड को सिमिलर कैटेगराइज ही कर रहे हैं, बट उन्होंने कैटेगरी अलग बना दी, पर समहाउ रिजल्ट दोनों का सेम ही आ रहा है. और ऐसा बहुत बार होता है बाय द वे. स्पेसिफिकली बैंगलोर के अंदर अगर आप फ्लैट्स देखने जाओ तो लोग बोलते हैं अनफर्निश्ड और सेमी फर्निश्ड, उनको कई बार इंटरचेंजेबली यूज करते हैं. It means you have a problem in your data itself where they are not properly able to classify between semi-furnished and unfurnished, and that's why 80% of the times they're highly correlated. I think 60% का reason भी यही है, क्योंकि एक क्लासिकल डिफरेंस नहीं है. तो कोई थिक लाइन नहीं है कि ये इसको हम सेमी फर्निश्ड बोलेंगे और किसको हम अनफर्निश्ड बोलेंगे. कुछ लोग किचन पूरा बना हुआ है उसको भी अनफर्निश्ड बोल देते हैं, और कुछ लोग नहीं बना है उसको भी सेमी फर्निश्ड बोल देते हैं. दे आर till now interchangeably using these two keywords. So at that moment हम डेटा में क्यों अलग अलग एंट्रीज को फीड करें अगर दोनों का पर्पस ही सिमिलर सिग्निफाई हो रहा है? सो इन दैट केस वी कैन डेफिनेटली रिमूव दैट सेमी फर्निश्ड एंटायरली, और हम सिर्फ अनफर्निश्ड को लेके ही फर्दर काम करेंगे. हम क्यों दोनों को लेके करें? दैट्स द
मतलब
सिंपल
आप बोलना
सिग्निफिकेंस ऑफ
चाहते
दैट.
हो कि जो हमारा कैटेगरी है सेमी
हम्म.
फर्निश्ड अनफर्निश्ड, आउट ऑफ दो कैटेगरीज में से हम एक कैटेगरी को ही डेटा से ही हटाएंगे. आप
डेटा
ये.
से ही हटा देंगे. हाँ.
ओके.
जब हम मॉडल
ओके.
को काम करेंगे आगे ईडीए के अंदर ही हमको हटा देंगे. हम सिर्फ एक को रखेंगे क्योंकि हम ये बोल रहे हैं कि 80% टाइम तो वो सेम ही इंफॉर्मेशन दे रहा है. तो क्या मतलब रखता है कि हम उसको फीड करें, फीचर इतने बढ़ाएं? कोई मतलब नहीं है, कोई सिग्निफिकेंस नहीं है. तो वी विल रिमूव दैट एंटायरली. एक फीचर, दोनों नहीं, एक एक को रखेंगे, इनमें से किसी एक को रख लेंगे और एक को हम कंप्लीटली रिमूव कर देंगे.
ओके.
दैट्स द
मैम
मीनिंग.
मैम
ठीक है.
अगर इसी पे एक सवाल है, जैसे का मान लीजिए 60% भी अगर सेम इंफॉर्मेशन दे रहे हैं, तब भी क्या हम लोग हटा देंगे या फिर दोनों को रखेंगे? अगर 60
अभी के लिए हम रख सकते हैं, बट आप अपने प्रोजेक्ट को करने के बाद एक बार फिर से रीट्राई कर सकते हो उसको हटा के, एंड यू कैन इवेल्युएट द परफॉर्मेंस. आई बिलीव बिकॉज एज पर माई वट एवर प्रोजेक्ट्स आई हैव वर्कड सो फार, 60% में हटाना सही नहीं रहता बिकॉज इट इज गिविंग सम हाउ इंफॉर्मेशन डिफरेंटली. हाँ, अगर 80% जैसे विनीत जो केस बोल रहे थे उस केस में तो डेफिनेटली यू कैन गो अहेड, क्योंकि 80% टाइम सिमिलर इन्फॉर्मेशन देना मतलब इट्स अ वेरी बिग डील. ऑल्दो 50 से ऊपर भी हो रहा है तो बिग डील है, बट 80 तो इट्स वेरी श्योर कि वी नीड टू रिमूव एनी वन ऑफ देम. बट इन दिस केस स्पेसिफिकली 60% is something which we can entertain. One more major reason why we can entertain here is that we have limited features here. If let's say we are working with a data in which let's say I will be having 20s 30s of features, in that case might be I will think over it, and at the end of the day I told you the best way could be where you can try for one time preparing a model in which you can remove that. Another time if you have any confusion like this, see there is no as such नंबर विच एनीवन गेव टू अस कि इस नंबर पे काम करोगे तो हटा देना, इस नंबर पे करोगे तो नहीं हटाना. इट एंटायरली डिपेंड्स ऑन विच डोमेन यू आर वर्किंग इन एंड विच काइंड ऑफ डेटा यू आर करंटली वर्किंग इन. सो if there is any confusion you are coming up with, the only way is doing a hit and trial, and you can experiment that if I remove that, what is the outcome I'm getting, what is the mean squared error I'm getting, is that low, or if I'm not removing that, at that point of time which particular score I'm getting. You can compare that, and accordingly, whatever model is giving you best result, you can deploy that for a test part. So this is how things will go. But for now, I don't think it makes sense to remove as a 60% wala part. I'm dealing with this data for the very first time with you all, and the only reason is so that we can completely work together, and we will see कि कहाँ पे हम ये result लेके जाते हैं. That's why मैंने भी उससे पहले कभी टच अप नहीं किया इस डेटा को, साथ साथ ही करते हैं, and we will look into it कि how we can proceed ahead at every point of time, at every stage. ठीक है? That's where we will have a fun as well, right? If we don't do it, the categorical data is of no use. We need to drop it. Data is reduced. Definitely, I think Mayank has answered the question of Afroz, and it makes sense as well. So shall we proceed ahead? I think the purpose of feature engineering, feature selection technique, which is a correlation coefficient, is also pretty much clear to everyone. The purpose of converting the object type to categorical data is also clear to everyone. The purpose of doing a one-hot encoding is also pretty much clear to everyone as a part of a EDA. The purpose of doing a calculation of, calculating the number of missing values is also clear to everyone. So there are multiple steps which we have done till so far, and that's a good job, right? हर एक स्टेप में ईडीए के अंदर आई थिंक दिस इज अ वेरी गुड बैच लकीली आई गॉट where you are asking some amazing questions from me, and literally I am also enjoying. It's been 2 hours I am speaking, and I don't feel like कि अभी 2 घंटे हो भी गए हमारे बैच को शुरू हुए, मतलब क्लास को स्टार्ट हुए, क्योंकि we are you guys are so much interested and curious to learn each and everything कि why you are doing so, why you are doing that, and I hope you guys are also enjoying the class, right? The implementation part which we are doing. So please just make this curiosity till the very end of ML sessions, and I hope that we will definitely learn from each other a lot, and we will grow together, right? So shall we proceed ahead with the next stage, where we will see what more things we can do as a part of our EDA? Perfect.
Yes, ma'am.
So the next thing which is required here is the feature scaling, which we have already discussed. That is a conversion of this particular data to a standard normal form. Uh, Before doing the conversion, let's try to see the box plot for this particular graph, and I'll showcase you that how basically we can create a box plot and what is the purpose of this box plot. Anyone who is aware about the box plot? What is the meaning of that? Why we create that?
Ma'am,
It
To
shows the
detect the
percentile.
outliers.
Anyone?
ma'am, we use blocks plot to outline the outliers to see if
Perfect.
the outliers are present in the data set or
Uh,
not.
Great. So what I can do is I'll just copy this code, and it's very simple to plot that. So what we can do is instead of calling heat map, I will call the function as a box plot. Data frame dot core is not required. We can say our data is nothing but data frame. Now let's try to see how this plot looks like, first of all. Oh, perfect. So here, that is the simple thing which I want to convey. Why before doing a feature scaling, I have done this plotting part. Can you see for all the columns that we have, maybe if you can increase this figure size to a more, 20, 20, this overlapping will not be there.
The figure size means in x-axis with 20 points will be there and y-axis 20
Yes.
points will be there.
Yes, the size of the dimensions, X and Y you are trying to convey. So because there was a overlapping, I think this is disturbing a lot, but it's okay. We can save the image as well, and then we can check it out. Let me just save it. So there's a function in PLT. You can use save fig here. Uh, Sometimes there is a distortion happens in the environment. So you can just save this image, box plot dot, let's say you want to save it in the form of a PNG. So once you run this code, it will show as well as I think it will be saved. Now the distortion is not happening anytime soon. So let me just show you how this image will be saved. You can just download this image. And these images are very important to download because when you show to the client your EDA steps and everything, what you have done, or your manager, you will have to create a proper PPT. And these images, oh, there is some, okay. Let's do one thing, one mistake I have done. I think this should be upper. Let's rerun this again. And let's download this again. So can you see this beautiful image is coming up and we have saved that. So what I'm saying is, whatever images you are trying to create, for example, correlation, coefficient, heat map also today we have created. So at every point of time, just make a habit to store this image also save this image also in a form of PNG or JPEG, or you can see the format which is looking good. I don't remember, there was one format in which it gives a very great image, great quality image. I will
SVG.
SVG, yeah, that's a correct answer. So when you're trying to create a PPT, in that case, make sure you will take a appropriate format in which your pixels of the images looks good, because that makes a difference, right? When you're trying to show to the PPT in a proper projector. So by the way, when you are seeing this particular image, you can see that why the scaling is important now. Why I was saying to you that scaling is important, because anyhow this price though we have to drop, but the remaining features which you can see, for example, this area, bedroom, bathroom, stories, parking, although they are almost equivalent in the form of a box plot, but somehow in terms of the numbers, we have clearly seen that, these area is somehow a little bit higher quantity as compared to the other features that we have. Apart from this, I cannot see as such outliers availability in our data set. Maybe in the upcoming part of our sessions where we will discuss further data, you will observe that outliers will also be available. At that point of time, we will do a discussion that how can we handle that. But for today, I think we can directly jump
Ma'am,
towards the scaling part.
ma'am, just to be
Yes.
sure, ma'am, can you tell me inside the box, these are the normal values, and outside the box, these are the outlier points, ma'am? I just
Yes.
want to be
So,
sure.
yeah, it's correct. So a box plot is composed of 5 important values. I'm just giving you a brief recap. So if you want to again explore in a depth, please refer the sessions of stats. I'm again repeating a humble request. So here you can see in a box plot, you will always observe that it looks like a 5 points combination, where the upper point is the upper whisker, which we usually say in statistical terms. This is something which we say as the value of Q2, which is 50 percentile. This is something which we will say as a value of Q3. This is Q1. And this is something which we call as a lower whisker. Now, how can we evaluate that? There is a formula to evaluate, which is Q1 minus 1.5 times of IQR, interquartile range, which is the difference between Q3 minus Q1. Right? And upper whisker formula to evaluate is Q3 plus 1.5 times of IQR. Today, I will again provide you a task video where I will refer these conceptual videos of this box plot in my playlist. I'll give you the link in the description of this dashboard part, and you can just refer that if anyone is not aware. Numerically, how can we plot? I will show you the demonstration of that from my videos, and you can please go and check it out. But anyhow, just to give you illustration, so whatever points are above this upper whisker and whatever points are below this lower whisker, all those points are a part of outliers. And that's why you will observe that this box plots are very widely used in order to detect the outliers. And once you detect that, there are separate statistical ways that we have via which we can handle that. Maybe we can talk about that in the upcoming sessions when we are talking about further projects where we will dealing with a classification based scenario in which genuinely outliers will be available. But for now, I think this much knowledge is enough. And let's proceed ahead, where the next task is to talk about the further step. Shall we move ahead? Are you ready? Can we do the
Yes,
scaling
ma'am.
now? So you know that for the scaling per se, definitely we require to do the scaling for the numeric data that we have, integer values, because we have to specify a range from -1 to +1. Remaining are categorical only, where we will be having true and false. We don't need to do anything for that. So let's see how we can do the implementation of scaling. So there is in sklearn, we have a package of pre-processing, as it's a part of a EDA, pre-processing only. We can import something called as standard scalar. Okay? Standard scalar. Now, what will happen? You will call this function standard scalar. I will talk about that how internally this function is working in a few minutes, but I'm just showing you the implementation, that how can we do a scaling of numeric features available in the data. Okay? So for that, first of all, we have to collect all the numeric features as well. So what you can do is you can say data frame, and inside that you can collect all the numeric features that you have. Now, what are those? So we can do one thing. We can say data frame dot columns, which will give me a list of columns that I have. So I think price is something we don't really care because it's a target value. We are focusing on the area part. So I'm just copying that particular region. Area is the one. Another one, what is the numeric one? Bedrooms, I think.
Bedrooms.
What is that next one?
Stories.
Bathrooms is also integer. If you want, you can re-verify with the above code. Stories is again a numeric one, int type. Any other thing? I think parking is also the one, right? Remaining are, I think, categorical only. So parking. Done. Now, what we have to do, we have to apply something called as scalar dot fit underscore transform. Don't worry, I'll talk about all these functions, internal meaning and how it is working with the mathematical part. Let me just first of all complete this stuff. And inside that, you have to again mention whatever columns you want to do. So it will just do the scaling of these features and again update it inside this particular features. So once you do that, okay. And again, if you will just try to check your values of data frame dot head and top 30 records, let's say, you will be easily able to observe all the values are updated. And now area is also not having that bigger value of 7024, 7026. Everything is in a specific range. Smaller ranges are there. Now, the question which might be you will be having in your head is that, Priya, how is this conversion is happening? And you have used something called as fit underscore transform there in your data set. What is the literal meaning of that? Let me try to talk about that. As I told you, there is a concept of z-scores which come into picture in this case. So let's discuss that part and then maybe we can proceed with the next part. Standard normal form. So how the conversion happens? So I'm giving you a very simple example, right? Let's say you will be having something called as an age feature in your data set, F1. And let's say you are taking an age of the patients or any customer that you have. Let's say it will be 21, 25, 27, 44, 47. Let's assume these are the records we have. And I want to convert that into a standard normal form. So with the help of the z-score formula, which is saying xi minus mu by sigma, it will do the conversion. What is mu? Mu is the average. So what will happen is it will try to take the complete average of this age. So you know the average could be 21 plus 25 plus 27 plus let's say 44 plus 47. So in total, how many points you have? It will be 5. So let's assume that this average is coming out to be some quantity, which is maybe 29. Now, this is assumption. I'm again saying it's not a correct calculation. Similarly, you will try to evaluate the sigma value. What is sigma? Anyone knows? How basically we can
Standard
evaluate
deviation.
standard deviation? It is nothing but is the summation of I equals to 1 to n number of data points that you have, xi minus mu divided by number of data points that you have, whole square. So you will try to take the value of xi, which is 21, minus this 29, square of that divided by 5. So you will do the same thing for the entire data points that you have, and you will do the addition of all of them. Let's say you're getting some answer as maybe you can say 10 or 5, anything like that. Now, what you will do is you will try to take each and every data point, which is let's say 21, minus you will say mu value is 29, divided by sigma is let's say 5. So you will try to see that what is the value it is giving to us. It is in a negative form, right? So this is how basically each and every feature, by applying the same value, it will give us the result in the standard normal form, where the range will be specified within the value of 1, -1, 2, and so on. So basically, this is how the conversion will happen from a given data set to a standard normal form via this formula. And this is famous by the name of a z-score, right? Xi minus mu by sigma. It should not be divided just by mu only, like this. Whole division is happening. Okay? This is how the evaluation is being done. So when you are using this particular function called as fit underscore transform, so what is happening? This fit is fitting your complete data and try to evaluate the value of mu and sigma, just like the way I have shown you. And this transform is a separate function, which is basically transforming all the records with a calculated value of, with a fitted value of mu and sigma. So if you want, you can also call this separately. Firstly, you can call fit function, then you can call transform function. But later on, researchers have said that why to write multiple lines of code? Why not to create one function altogether, which is also doing a fitting and transforming? And that's where this fit underscore transform came into picture, where all the recording with a fitted value of, or you can say all the evaluations. पता नहीं recording मैंने क्यों लिख दिया? Evaluation with the fitted value of mu and sigma. So this is the real purpose of calling this function called as fit underscore transform. तो fit क्या कर रहा है? Fit function basically help कर रहा है to get that value, which is that simple, what we are saying it as mu and sigma. And this transform is basically trying to transform the records that you have. And this is how we will be able to get the entire specific ranges in a given particular data set. And now we are good to go. We have a price column, which we have not touched upon, and we will not even touch that. We just have touched upon the input features. And now the right time has come where we can move ahead with the data splitting part, where we will try to split our data into the input features and the target value. So shall we proceed with that step?
मैम इस डेटा सेट पे एक ब्लॉक्स प्लॉट दिखा दीजिए जो हमने
Okay.
नया बनाया है.
So when you will try to create a box plot for this specific data, so let's try to again see that. Maybe what I will do, I will try to showcase you the box plot of input features. अभी आप प्राइस का भी देख रहे हो, तो प्राइस का एक बार के लिए फोकस मत करना, right? प्राइस हमें नहीं देखना है. We are just focusing on input features. So let's again see that, the updated one. So you can see now everything is in one smooth pace. Maybe आपको plotting में इतना difference भी समझ में नहीं आ रहा होगा, because the numbers are very, very small in the above and the below cases. But you can see in the exact term that there is a difference in the previous number and this number. This pricing is something you can ask from me that this is having a very huge number, but we don't take care of this. Why? Because it's a target part. We will anyhow remove this. That's the reason. Okay? So now let's proceed ahead with next stage of our pipeline, where we will do the model split. Model preparation, I would say model preparation, in which we can do the train and test split. This is the next phase where we will try to split our data into training and testing. Usually there is some other term called as validation also. When the concept of hyperparameter tuning will come into picture, I'll talk about that as well. But for now, we are trying to split our data into training and testing. How can we do that? Let's try to understand that and why it is even required. So आपके पास, let's suppose you will be having 1,000 number of data points available with us. You will be having 1,000 records available with us, right? So let's say. कर सकते हैं ना अभी हम आगे? Are you guys interested to proceed ahead? Are you
Yes,
guys
ma'am.
enjoying?
Yes,
Shall we
ma'am.
extend
Yes, ma'am.
half an hour more this session?
Yes, ma'am.
Everyone is okay? Okay,
Yes,
perfect. So we will be having, let's say, 1,000 records available with us. So what usually happens is, in this specific record, we will try to split our data into training and testing. अब ऐसा क्यों करते हैं? Because definitely before we will deploy our model, we have to check that whether our model is working fine or not. So maybe what we usually do is we will try to split our data into, let's say 80%. So maximum portion you will try to feed into training part, and minimal portion you will try to take it into a testing part. And 20% you can take it as a testing part person. Okay? So you will do a splitting of that particular data into training and testing. So what will happen? What we will do in the future part, we will apply our linear regression algorithm, and we will create our model on this training set in the training data.
Ma'am,
And
मैम हम
this,
लोग
just wait. Give me a few minutes and then we will take your question. We will try to train our model of linear regression on this training data. And with the help of which we will be able to get our final optimized value of that MNC. And because here we will be having multiple features, so definitely you will be having, so how many number of features we have in this specific data set? So if you will just see data frame dot shape, so you can understand we will be having 14 features, out of which one is a target column. So it means that 13 features are there, genuine input features are there. So we will be able to get the value of M1, M2, M3 until the value of M13. Also, we will be able to get this value of C, which is an intercept. So these coefficients, you will be able to get that. And then what we will do is at the end, in our complete pipeline of a project, we will try to test our data on these coefficients, which we have saved. We will save it in a pickle file, and we will try to use these coefficients to test our model. And we will get the predictions of this test data, right? We will get the predictions of this test data. And then you also know that in this test data, we also have a target value available with us. Means target price is also available to me, which is why I have a predictions, which is y cap. And then at the end, I will try to evaluate the mean squared error, which is the phase of model evaluation, in which I will check that what is the difference between my actual and prediction part. Definitely what I want is, I want it to be as low as I can make it. And that is the real goal which we want to achieve here. So now you can ask me question in this entire story if you have anything. Prabhutva, please ask.
No, ma'am, understood. I was asking why we were splitting. Why can't we know first of all train 100% data and then do it after testing? But now I got the answer.
Okay, perfect. So let's move ahead to the model splitting part. So what we can do is from sklearn again, we have something called as model underscore selection. Inside this, we can import a function called as train underscore test underscore split. So this will help me to split my data into training and testing. But before that, definitely, as of now, I have a whole huge data frame which is available. We have to split the data frame into input and target variable as well. उससे पहले तो हमें ये भी करना पड़ेगा. So let's do that as well. So what we will do, we will take our X, and what we will do in this case, so if let's say I want to drop one of the column, what is the column I want to drop? What is
Price.
my, yes, price. So what we will do, what's the spelling? I think it's in a small, right? So price, I will drop here, and column wise, I want to make a drop. So X is equals to 1. So I have made that parameter as 1, which indicates column wise, complete column you have to drop. Okay? And Y is something which is the target which I have. So what I will do, I will take a data frame. Inside that, I will say take price only. So now what happened? Y will become my target variable. X will become my input features. So now what I will do finally is I will try to split my data into training and testing. So I'm writing a code for that. X train, X test, Y trained, Y test, because this is what you will split. You will split this X and Y into training and testing. So how will you split? You will call this function train underscore test underscore split. Inside that, you will pass the parameters which you want to split, which is in our case X comma Y. Also, you can pass the ratio, which is test underscore size. Let's say I'm saying take almost 20% of my data in the testing part, and remaining you can consider it as a training part. Apart from this, there is one more variable that we have called as random state, which is equals to, let's say I'm saying 44. Now, what does this parameter says? This
It is
parameter
like
says that usually what happens is when you are trying to do a split, it is doing a random split. Now, let's say you and me working with the same project. And what we want is at every point of time, whenever we are training our model, this split will always be same. This randomness will always be same. Means whatever be the number of records I'm getting in a training set, and whatever be the number of records I'm getting in a testing set, this should be same. This should not be changed. In that case, we will have to use this parameter called as random underscore state. This can be any number you can define. But if you want your friend and you will get the same set of data points, definitely you should have a same number in that case, right? So this is how we can do the split of the data. And now, once we run this code, we are ready with our training and testing set.
Ma'am,
Any doubt
here
in this part?
44 means 44 records, right?
No, it's not 44 records. Its meaning is that you can also make this 42, 41, 40, 32. Its meaning is that when you are doing a splitting of your data, for example, now at every point of time, when you are trying to see this x underscore train, how it looks like, and x underscore test, how it looks like. So you will have some random samples, right? You will be having almost 436 number of rows in the training and 109 number of rows in the testing. And you can see in the initial part, you will be having 152 reports. So at every point of time, when you will do the split, you will get the similar number of reports every time. Can you see? Similar number of reports you're getting. At every point of time, similar number of reports you will be able to get. If your random set is same. So what I'm saying is, at every point of time, if let's say you are also applying this random set as 44, you will also get the similar samples, which I'm getting here. 436 number of rows here and 109 number of rows here. If you will not apply this, it's an optional thing. In that case, you will, at every point of time when you're running your code, you'll get some different samples of 436 size, right?
Got it. Ma'am.
Ma'am, please repeat. I am not able to understand what exactly random state is doing.
So let's try to remove this altogether and let's run this. So can you see when we are applying this, we're not applying any random state. So what is happening? In the initial part, we're getting 91, then 361. We are getting any random sample in which 80% is going towards training side, 20% is going towards testing side. So we are getting randomly 436 rows. If I rerun this code, क्या हुआ? कोई और ही sample आ गया, right? We're getting some different sample altogether. So at every point of time when you run this code, you will get entirely different samples. होगा वही कि आपके पास में what will happen is in the training part, you will get 80% of the size of the samples, 20% will go to the testing side. But randomly, you will get different samples whenever you are running a file, whenever you run a collab file. If you want to fix this number, कि मेरे को हर बार जब मैं रन करूं अपनी फाइल को, तो मुझे सेम सेट ऑफ सैंपल्स ही चाहिए, मुझे बार बार चेंज नहीं चाहिए क्योंकि इससे वेरिएशन हो रहा है. At that point of time, you can fix any of the number, whatever you wish, and then this sample set will be fixed. कि इतने यही सैंपल्स टेस्टिंग में जाएंगे और यही सैंपल्स जो है वो ट्रेनिंग में जाएंगे. अब आप दोबारा रन करके देखो तो आपको दोबारा यही सेम आंसर मिलेगा. That is the difference. Is it clear to everyone?
और मैं 44 का क्या सिग्निफिकेंस था?
कोई भी नंबर लिख सकते हो. मतलब कि इंटरनली व्हाट दे हैव डन इज कि हर एक नंबर पे उन्होंने सेट कर रखा है कि अगर इस नंबर पे कोई मैपिंग, इट्स काइंड ऑफ अ हैशिंग और डिक्शनरी लगाया हुआ है कि अगर ये की होगा तो 80% ये वाले
अंडरस्टूड.
जाएंगे और 20% ये वाले जाएंगे, 40 होगा तो वो वाले जाएंगे. कोई भी नंबर आप यहाँ पे इंसर्ट कर सकते हो अपनी विश के हिसाब से.
और मैम रैंडम स्टेप इज इक्वल टू, अगर कोई नंबर ही स्पेसिफाई ना करे तो एरर दे देगा ना मैम, अगर कुछ लिखे ना.
अभी मैंने दिखाया ना, अगर आप इसको रिमूव कर दोगे तो इट्स एन
नो मैम,
ऑप्शनल थिंग.
मैम बस ऐसे ही लिख दो रैंडम स्टेट इक्वल टू 0 या 1, ऐसे कुछ भी.
0 लिखोगे तो भी नंबर स्पेसिफाई होगा इंटरनली, राइट?
ओके मैम,
और
अंडरस्टूड.
अगर आप इक्वल टू करके कुछ लिखोगे नहीं तो ऑब्वियसली एरर देगा कि मतलब आप क्या करना चाहते हो. अगर आप ये बिल्कुल हटा रहे हो so it is not doing anything, right? It will not give an error. It's an optional thing. If you are writing it, just write some number, it will give you according to the output. Okay, now the next important step, the next pipeline is to do the I would say model training. So let's do that. So अब हम यहाँ पे लगाएंगे अपना linear regression model जो हमने last class में पढ़ा था, right? So what we will do, from sklearn, there exists a linear underscore model, and with that you can just import the model name called as linear regression directly. Okay? And what metrics you want to go for the evaluation purpose? I want to go for a matrix called as mean squared error. So it is available inside this metrics module. I will import something called as mean underscore squared underscore error. let's do one thing. Let's try to create a model. So how can you create that? You will call this linear regression model. And after this, you will try to fit this model on the training data. So you will say model.fit, and whatever be the training set you have, you will just fit in that specific data, which is X train comma Y train. So you are passing the input features, you are passing the target value as well. So it will help your model to do the fitting, and it will be able to understand internally the pattern. And accordingly, it will try to give you the value of that coefficients of M1, M2, M3, M4 until M12 or M13, and that intercept value. So what will happen once you run this particular model? You will be able to get that model file available with you. And let's say now I want to do a prediction. So what will happen? In the model, you have a function called as predict. What you will do, you will say y underscore test. And now, if you will just check it out, you will be able to see the predictions. There is some issue which it is showing to us. X underscore test, sorry. So we will pass the input features, which is X underscore test in our case, and we will be able to get the prediction. So you can see how amazingly you will be able to get the prediction of the price, house price in a entire part. So you will be able to have the predictions of a house in this case. Now I want to see that with respect to this model, what is my mean squared error for this predictions which I'm getting? That's the actual thing, which is the last stage of our pipeline, which is model evaluation. Let's do that. And here you will say MSC is equals to, you will say mean underscore squared underscore error. And you will pass what is the predicted value that you have and what is the actual value that you have. So you will pass y underscore test is my actual data and y underscore pred is my predicted data. So now what I can do, I can just print that value of MSC and we will be able to see that. So you can see it is this specific value which we are getting. This is the mean squared error for this specific file which we are getting, right? So we will see in future that how can we optimize that? Can we apply some other algorithms on top of this? Definitely, it's not a good one, but this is how the complete flow of the pipeline of a linear regression model looks like. And this is what we have done, where we have seen the splitting part, model training part, and finally the model evaluation part. Now, if you have any issues, you can ask. I think now we have finished our work in terms of doing the complete pipeline part. How optimization we will do in future, that is a separate discussion altogether, because as of now, we have taken the default parameter of linear regression. The task for today's session is at your end, what you have to do before coming to the next classes, just go to the documentation of this linear regression documentation. Okay? And try reading this documentation. What are the parameters we have? Like what are the parameters we can define? All these things you have to read it out. One more thing which I can showcase you here itself, model dot. You can try to see the value of coefficients, which is M1, M2, and so on in this specific case. So you can clearly see that this is M1, M2, M3, M4, M5, M6, M7, M8, M9, M10, M11, M12, M13. So basically the intercept is C. I think 12 features we have. So how many features we have? X underscore train dot shape. Yes. So in total, we will be having this 13 number of features. So in this case, you can see that many values, that many M1 to M13 value you will be able to get here. If let's say you want to see the intercept, so you can say model dot, I think there is a function of intercept as well, if I'm not wrong. Let's check it out. So you will be able to get that value of C as well. So if you remember, I have talked about multiple linear regression. I told you that if let's say you will be having multiple features available, so in that case, that means number of slop values you will be able to get in a line. So this is that values which you will be able to get, because we will be having 13 features, 13 slop values are available, and this is the value of C which you will be able to get. So today's task after this session is to refer this documentation and read each and everything, right? Whatever the parameters we have, how basically they are signifying. Almost everything I have talked about here, but still, please do give it a read. It's a one-page documentation. And I think next part of discussion we will do in the next upcoming session.